All right, hi class, I apologize for not being here today. I will be out for a math training with other teachers. Please welcome our guest teacher and be respectful. I expect you to all be on your best behavior today. For our lesson on Canvas under modules, you'll see today's lesson slides. We're starting a new unit, so we will start by making a new cover page together with our video. Please remember to complete an exit ticket and one iReady lesson at the end of the lesson. And then if you finish everything, then you may begin working on homework in class. All right. All right, so let's look at our agenda for today. We're going to start by making a cover page. We're going to work on some notes together. There is an exit ticket at the end, and you're going to complete, instead of one iReady lesson. And then here's your homework. Make sure when you're looking for your homework in your textbook, remember that we're starting a new unit. So you got to look for comparing and scaling unit from your textbook. All right, so we're going to start taking notes. Remember, whenever you see the stars, you got to have your pencils ready and you're going to write things down in your notebook. So first thing in your notebook, you should set up a new cover page, Unit 2, comparing and scaling. So make sure you put that title on a new page in your notebook. And the first word that we're going to write and highlight is ratio. Make sure to do that. And here is a sample of Ms. Park's cover page, Unit 2, comparing and scaling word ratio. Pause the video, give yourself some time to set up your notebook, write down the word, and highlight. And once you have done, please come back to the video. All right, if you have done that, then we're going to start a new page in our notebook for our new unit. The lesson title, we're going to write it down together. It's going to be 1.1, analyzing comparison statements. And then write down the focus question as well. In what situations would a ratio be used best? And on the slide, I highlight the word ratio because that is a new vocabulary for our new unit. So I'm going to highlight it again. All right, so before we start our first problem, we're going to look at some background information. You may watch this video on your own if you would like to, but I'm going to start off by reading the context here on the screen. Okay, so you can look at the screen, read along with me. It says companies that sell soft drinks often report surveys results about customers' preference. So as you can see on the poster, it says, which soft drink do you like the better? Bolda Cola or Cola-Nola? Take the cola taste test yourself. So the Marketing Club and Nielsen Middle School is studying surveys and other marketing strategies. One of the surveys about people's preferences for two different kinds of cola. So we got the Bolda Cola and Cola-Nola. Club members have various opinions about ways to report the results from the cola taste test. So we're going to look at what people prefer. Do they prefer Bolda Cola or Cola-Nola? All right, so now here are 4 statements about the soda taste test results. So we're going to look at the actual statements about the results, and we're going to answer some questions. So the first statement, it says, in a taste test, people who preferred Bolda Cola outnumbered those who preferred Cola-Nola by a ratio of 17,139 to 11,426. Number 2, in a taste test, 5,713 more people preferred Bolda Cola. Number 3, in a taste test, once again, 60% of the people preferred Bolda Cola. Then number 4, in a taste test, people who prefer Bola Cola outnumbered those who preferred Cola Nula by a ratio of 3 to 5. I'm sorry, 3 to 2. Okay, so if you would like, you can pause the video and reread those statements. But once you have read the statement, please write problem A in your notebook and answer those 3 questions by writing your responses in your notebook. And then you can come back to the video and go over with Ms. Park. All right, so now let's go over some of these 3 of these questions together. So after reading the statement, question number 1, what conclusion can we make about the soda taste test result based on the 4 statements? Well, what is one conclusion we can come up with? Well, all of these statements are saying the same thing, that people preferred Bola Cola more than Cola Nula. Let's write. People prefer Bola Cola. Or we could say more people prefer Bola Cola. And then number 2, which of the statements do you think would be best in an advertisement for Bola Cola? Why? Well, when you guys think about advertisements, it has to be quick and it has to catch people's attention. Right? And if you want to advertise about Bola Cola, you want to give a statement that draws people's attention and tells them, people why they prefer Bola Cola. So I think the best statement, you could choose 2 options. I could say that statement number 3, right? In a taste test, 60% of the people preferred Bola Cola. Or statement number 4. In a taste test, people who prefer Bola Cola outnumbers those who preferred by a ratio of 3 to 2. I think statement number 3 and statement number 4, they use smaller number and they're easier to relate to. So they could be the best one to use in an advertisement. Like statement number 1 and 2, they use a lot of large numbers, right? But 3 and 4 are smaller. So it really catches our attention and it's easier for people to relate to. So we're going to write that down. We're going to say statement number 3. That's the one with 60%. And statement number 4. And that's the ratio one, 3 to 2. And we're going to say those might be more effective because the numbers are smaller. And easier to relate to. Okay, last one, question number 3. Suppose you surveyed 1,000 soda drinkers. What number of Bola Cola and Cola Nula drinkers would you expect? Okay, so we know that 60% preferred Bola Cola. So 60% prefer Bola Cola. And if there are 1,000 people, how many people is that? What is 60% of 1,000 people? Well, you could try. 60% as a decimal is 0.60. So if you multiply that, the total of 1,000 people, that's going to be 600. So 600 prefer Bola Cola. 60% of 1,000 people is 600, which means how many people prefer Cola Nula? 1,000 minus 600, 400 people preferred Cola Nula. So that's a total together, 1,000. Okay. All right, so now we're going to take some notes together in our notebook. Let's first copy down the ratios definitions. So what is a ratio? Ratio is a comparison of two quantities that can be expressed in many ways. So let's write that down first. So ratio, underline a comparison of two quantities that can be expressed in many ways, can be written in many ways, right? All right, so for example, let's copy down the first one. Ratio can be written in words. Let's say you have 2 to 5. You can also write that with semicolon like this, 2 to 5. Mathematicians are lazy. They like to use symbols rather than writing out the words. Okay, you can also write it as a fraction. First number goes in the numerator and the second number is a denominator. So 2 over 5, the same thing as 2 to 5. Now let's also write it as a decimal. How do we write that as a decimal? Well, if you're trying to write it as a decimal, you have to divide numerator by the denominator. So it's like doing 2 divided by 5. If you do 2 divided by 5, that as a decimal, if you put it in the calculator, I'll do that for you, it is 0.4. So 0.4 as a decimal is another way to write the ratio. So 2 divided by 5, let me show you that real quick. 5 does not go into 2. So we're going to put a decimal point 0, and you have to put a decimal point and add a 0. So then now how many times does 5 go into 20 or 20? 4 times. 4 times 5 is 20. Subtract is equal to 0. So that's why the decimal is 0.4. Now the last one, important one, percent. How do we write as a percentage? Percentage is very, very simple. You take the decimal and you multiply that by 100. Multiply the decimal by 100. Simple ways to think about is percentages out of 100. So we're going to multiply the decimal by 100. So if you take 0.4 and multiply by 100, that is 40. And you're going to write that as 40%. Those are the 1, 2, 3, 4, and 5 different ways to write ratios. And we will practice that today. All right, so next slide. Let's read this together first. It says, some students at Oak Valley Middle School are planning an end-of-year event. Of the 150 students in the school, 90 would like an athletic event and 60 would like a concert. Please complete each statement. So you might make some conclusion here already about which, how many students prefer which particular event more than the other. So let's start with the first statement. We're going to write down problem B in our notebook first. So let's put problem B. Okay. So there were blank more people who preferred an athletic event. Okay. So how many more people prefer the athletic event? Well, 90 students prefer athletic event, but 60 preferred concert. So if you find the difference between the two, it's going to be 30. 30 more people prefer the athletic event. Okay, so that's finding the difference. Oops, I spelled athletic wrong. Sorry. Just the habit of putting an E there. Athletic events. And make sure you are writing with pencil, please. I forgot to mention that. Okay, number 2. Percentage of students. Certain percentage of students preferred a concert. So what percentage of the students prefer the concert? Well, let's first of all look at how many students preferred, right? So 60 students preferred concert. Okay, now 60 out of what? Out of how many total? Well, there are 150 students total, right? So if you write that as a ratio, it's 60 students prefer concert to 150 students total. And remember, how do we write a ratio to a percentage? We're going to divide 60 and 150. So we're going to do that in our calculator. I'll show you that real quick. I'm going to do 60 divided by 150. I got 0.4. So we turn the ratio into a decimal, and then we're going to turn that into a percentage by multiplying 100, which is 40. So 0.4 we're going to multiply by 100, 40%. So we know that 40% preferred an athletic concert. I'm sorry, not athletic concert, preferred a concert. They combine the two together. Okay. Now, number 3. People who preferred an athletic event outnumbered those who preferred a concert by a ratio of, so we're going to write that as a ratio. What is a ratio of students who preferred athletic event to students who preferred a concert? We're going to write that as a ratio. They give you the template. 90 students preferred athletic event, so 90 to 60. Okay, 90 to 60. That's the ratio we can write. Now, yes, you may do this. If you want to reduce this ratio, you can write the answer as 9 to 6. That is actually another option. These are equivalent. This is another same ratio. It's like you're dividing them both by 10. So you can also write it as 9 to 6. All right, so now I'm going to share with you fun ratio facts. So let's look at some of these two situations. What is more likely to happen to us in our real life? So first one, it says the odds that one will be struck by lightning in the United States during one's lifetime are 1 in 15,300. That is actually another ratio that describes a chance of a person getting struck by a lightning. Now, you don't have to write this in your notebook because there's no star. Well, let me just show you real quick. If the chance of someone getting struck by a lightning is 1 in 15,300, let's see what that would be as a percentage. What is the chance of us getting hit by a lightning? 1 divided by 15,300. That's about approximately, and I'm going to write that, approximately 0.0000654, right? That's as a decimal. So if you want to turn that as a percentage, remember, we're going to multiply by 100. And then that times 100 is going to give us 0.00654%. That's the chance of a person getting struck by lightning in the United States during a lifetime. That is very, very, very small. All right. Now let's compare that to the next statement. Look at the slide. A rough estimate of a chance of an airplane going down due to an emergency is about 1 in 11 million. Okay, so let's see that as a percentage. 1 in 11 million. 1 in 11 million. I'm going to turn that also into decimal first. to put in my calculator, 1 divided by 11 million. Oh my God, look at all those zeros. As a decimal, I got 0.000000091. So many zeros. But then I'm going to multiply that by 100 to turn that into a percentage. And guess what's going to happen? You're going to get 0.0000091%. That's the chance of an airplane going down due to an emergency. So what is more likely to happen based on this ratio? Something that we don't really want to think about, but based on our theoretical calculation here, it is more likely for a person to be hit by a lightning in the United States during their lifetime. But as you can see, ratios can be very helpful when you're comparing two things that are really big in quantity. So then it's easier for people to make decisions or come up with their own thoughts, right? Looking at it this way, I mean, just like the earlier Colanola, when we were looking at statements that is the best for advertisement, we think the 60% or the ratio of 3:2, seeing it as a smaller number was easier for people to relate to. That's why they're being used. So we're going to go to the last part in our bottom of our notebook. And I would like you to take a moment to write the summary in your notebook. So make sure you label summary. And take a moment to answer the focus question. In what situation would a ratio be used best? The green highlighted sentence, that's a sentence starter. You may use that if you would like, or you can start your sentence with something else. Let's pause the video, write down your summary. All right, so for this lesson only, I'm going to share my summary with you to see if, we have anything similar, any similar response. So I said a ratio could be used when comparing two things that are big in quantity so that people can easily relate to it and make decisions. That's my summary. All right, so once you have finished the summary, now we're going to start the second part of our lesson. Okay, so we're going to start a new page. Or if you want to continue underneath your page, that's okay. I'm going to start a new page. We're going to title it with our number 1.2, Comparing Ratios. Comparing ratios. And then copy down the focus question. Focus question today is, what strategies do you use to determine which mix is the most orangey? So what strategies do you use to determine which mix is the most orangey? Okay, so what does this mean? Well, I'll tell you what it means and we look at our next slide. What do they mean by mix? What do they mean by orangey? All right, so on the next slide, we're going to read this together. So here's a little bit of context here. It says, every year, the grade 7 students at Langston Hughes Langston Hughes School go to an outdoor education camping trip. During the week-long trip, the students study nature and participate in recreational activities. Everyone pitches in to help with the cooking and cleanup. Now this year, Arvin and Mariah were in charge of making orange juice for the campers. They plan to make the juice by mixing water and frozen orange juice concentrate. To find the mix that would taste best, they decided to test some mixes. All right, so here's, I'm guessing, Mariah and Arvin, and they are making orange juices by mixing orange juice concentrate and water. Okay, so here are the different mixes. I have a next slide, a bigger picture of that. Okay, so here is their mixes. Mix A, B, C, D that they're going to be testing. Now, please take a look. And I want you to come up with your own response to these two questions. First, please choose the mix that will make the juice the most orangey. So you have 4 options, mix A, B, C, D. Look at the mix and choose the juice that is the most orangey. Explain how you know. Number 2, which mix do you think will make the juice that is the least orangey? And how do you know? Come up with your responses and write a brief explanation explaining how you have come up with that decision. When you are done. All right. So then now I'm here all by myself. I don't know what your responses were. I'm going to have to go through all the options. So problem A. I'm going to write down problem A first. Let's look at all options. Let's compare and see which one is most orangey. Now, here's what I'm assuming that you could have done. Some of you, for mix A, B, C, D, you could have tried to compare the ratio. So mix B, mix C, mix D. So what some of you could have done, mix A, it's 2 cups of concentrate and 3 cups of cold water. So some of you could have compared the ratio from concentrate, right? Concentrate to how much water they have put in here. And if you actually look at that as a fraction, right? I'm going to write the same thing for other one. Mix B, 5 cups of concentrate to 9 cups of water. 1 cup of concentrate, 2 cups of water, 3 cups of concentrate, 5 cups of water. Which one of these will make the juice that is most orangey? Which one will have more concentrate compared to water? Well, let's compare these numbers. These all have different denominators, and it's really hard to compare. So I'm going to turn them all to decimal. We're going to put 2 divided by 3, and that's about 0.66 or 0.67. I'm going to round it up. 5 divided by 9, that's about 0.56. Okay, 1 divided by 2, that's 0.5. 3 divided by 5, that is 0.6. So when you compare concentrate to water, which one of these have the highest ratio? It looks like mix A. It looks like mix A have the most concentrate to water. So we could say that it's mix A might be most orangey. Okay. Now, some of you could have done something different. Instead of comparing it to concentrate to water, some of you could have compared the concentrate to the entire mix. So we're going to try another one. Mix A, mix B, mix C, mix D. So let's look at the chart again. Coming back to the chart. Mix A has 2 cups of orange juice concentrate. Okay, but we're going to compare that to not the cups of water, but we're going to compare to the entire mix. So there are 2 cups of concentrate out of the entire mix, which is 5. Right? We're adding the 2 cups of concentrate and 3 cups of water together to get 5. This is called a part to whole ratio. Part to whole ratio. We're comparing part of the juice mix to the entire juice. The first strategy up here, it was a part to part ratio. We're comparing each ingredient part to part. We're comparing concentrate to water, part of the juice, comparing them. So let's see if we get different answers for part to part ratios compared to part to whole ratios. Okay, so let's do the same thing for mix B. Mix B has 5 cups of concentrate, but if we combine the 5 cups of concentrate and 9 cups of water, that's going to be 5 concentrate to 14 mix. Mix C, that's going to be 1 cups of concentrate, and we're going to combine the concentrate and water together, so 1:3 ratio. Mix D, 3 cups of concentrate, and we're going to mix the concentrate and water together, so that's 8 cups total for the mix. Let's compare it by turning them to decimal. 2 divided by 5, that's 0.4. 5 divided by 14 is about 0.36. So then 1 divided by 3 is about 0.33. 3 divided by 8 is 0.375. So let's look at it again. Part to part ratio. When we wrote a ratio from concentrate to water, we said mix A had the highest ratio. What about part to whole ratio? Let's look. Mix A, it still has more orange concentrate. So do they both give the same result? Yes. It's up to you. Did you use the part to part ratio or did you use part to whole ratio? Now let's go back to answer our questions now. So which mix will make juice that is most orangey and how do you know? So number 1, we're going to say mix A is the most orangey, and just write down what strategy you use. You could say I used part to part ratio and mix A was the highest. Or you could say I used part to whole ratio and mix A was the highest. Okay, and then the next question, it says number 2, which mix will make the juice that is the least orangey? Now let's go back. Part to part ratio, when you compare concentrate to water, what was the smallest ratio? Which mix gave the smallest ratio? Mix C, 0.5. That was the smallest ratio. So let's look at part to whole ratio. Same thing. Mix C gave the same answer of being the least orangey for part to whole ratio. So same result. It's up to you whichever strategy you use. So number 2, I'm going to put mix C is the least orangey. And you could say I used part to part ratio and mix C ratio was the lowest, right? Lowest ratio. Or you could say I use part to whole ratio and mix C was the lowest ratio. All right, so write down your response. All right, so this time I'm going to ask you to try this problem. I'm going to read the problem to you. I'm going to have you record your responses and come back to check your answers. It says, at Farmer John's barn, there are 18 pigs, 10 cows, 8 chickens, and 4 goats. Write a ratio for each situation and then decide whether the situation is part to part or part to whole. So for example, number one, you're going to write down the ratio for pigs to goats. It's up to you how you write it. You can write it as a fraction, decimal, percentage, whatever you want. You're going to write down the ratio and determine whether that ratio is part to part or part to whole. Label your notebook as you try, and then number 1, 2, 3, 4. All right, so let's see what you got. Number 1, pigs to goats. There are 18 pigs and 4 goats. So I wrote 18 to 4. That is a part to par ratio because the pigs are part of the animals in the barn and the goats are part of the animals in the barn. Now, number 2 makes a little bit more sense. There are cows to animals, a ratio of cows to animal. There are 10 cows. And how many animals are there? You got to add them all. 18 pigs plus 10 cows plus 8 chicken plus 4 goats. You're going to add them all together. And that comes out to be 30. There are 30 animals total. So 10 to 30. You could write that as 10 over 30, or some of you might have written as 1 over 3, reducing it. This is a part to whole ratio. You're comparing cows to the entire barn, animals in the entire barn, part to whole. Number 3 is John to animals. How many Johns are there? There's 1 John, and how many animals? 30 total. That is another example of part to whole ratio. Number 4, what percentage of the animals are pigs? As a percentage, so let's first write the ratio. We want to compare pigs to animals, and that comes out to be 18 pigs out of 30 animals. So what is that as a percentage? 18 out of 30. We're going to put that in our calculator. 18 divided by 30. We're going to turn that into a decimal. That is 0.6. And then how do we turn that to a percentage? We multiply by 100, and that will come out to be 60. 60% of the animals are pigs. All right, so we're almost done with this lesson, but let's look at something real quick. You do not have to write this down, okay? So as we do this ratio, we're going to talk about something called equivalent fractions. Equivalent fraction, you might have heard of this before. They are fractions that have different numbers in the numerator and denominator, but they are equal in value. They're the same. So for example, 1/2 is equivalent to 12 over 24. How do we know that they're the same? Well, that's because both numerator and denominator, you multiply them both by the same number. That's how you make equivalent fractions. Let's look at the second example. 6 over 9 is same as 2 over 3. They are equivalent fractions because if you divide both numerator and denominator by the same number, they have to be the same number, you get the reduced fraction. You have to either multiply or divide both numerator and denominator by the same number. So I want you to be able to answer these two. Can you determine whether the two fractions are equivalent or not? 5 over 12 and 15 over 36. Are they equivalent or not? Yes or no? The answer is yes. 5 times 3 is 15, and 12 times 3 is 36. So what about 3 over 5 and 12 over 15? Are these two equivalent? Well, answer is no. Top, you multiply by 4 to get 12, but the bottom, you have to multiply by 3 to get 15. So they are not equivalent. They're not the same number. Last problem of the day, problem B. Let's get ready for problem B in our notebook. Number 1, it says, a backyard pond has 12 sunfish and 30 rainbow shiners. Write the ratio of sunfish to rainbow shiners in equivalent, or I'm going to say, or reduced fractions. So number one, first of all, let's write the ratio of sunfish. There are 12 sunfish and 30 rainbow shiners. I'm going to put rainbow shiners. So that's 12 over 30. But they want us to write an equivalent fraction that is reduced. So we're going to reduce this fraction. How are we going to reduce it? We're going to divide them both by the same number. What is that number? I think 3. 3 is a number that you can't divide them both by, right? 3 is one same number. Yeah, you can divide 12 by 3, 30 by 3. 12 divided by 3 is 4. 30 divided by 3 is 10. So 4 over 10 is a reduced fraction. So that's one answer. But can you reduce that even more? Yes, you can divide them both by 2. You can divide them both by 2, and that's going to be 2 over 5. 2 over 5, that is the simplest, most reduced. I'm going to put most reduced. Simplest form, most reduced fraction. So 2 over 5, I'm going to put box around it as a final answer. Okay. Number 2. Miss Ekpebe's class has 32 students, of which 20 are girls. What percentage of the students in her class are girls? So here's another percentage problem. We have done several of these today. Please pause the video, see if you can find this on your own. Of course, you can use a calculator. And let's check. So what percentage of students are girls? So we're looking at ratio of girls to students in the class. So this is a part to whole ratio. There are 20 girls, and how many students are there total? 32. So 20 divided by 32, we're going to put that in the calculator. That's 0.625. So as a decimal, we have 0.625. But we're going to turn that into a percentage by multiplying by 100. So times 100, we get 62.5% as our answer. 62.5% of the students are girls. Right. Okay, very good job, my students. Now we're in for the last part. We are going to write down the summary. So, summary, you're going to answer this question. What strategies do you use to determine which mix is the most orangey? If you forgot, you can go back to your notes. But what are the strategies that we use or you use to determine which mix is the most orangey? Did you use, first strategy, which was a part-to-part ratio, or did you use part-to-whole ratio? Because it doesn't matter which one you use. They give you the both same answer, right? So write down in your response which strategy you use, and that is your summary for today. Okay, once you have done your summary, you're going to complete your exit ticket, which is a Google form. You're going to click on this link. It's going to open up to a Google form, and you're going to complete your exit ticket. Once you have finished the exit ticket, please make sure we return. If you borrowed a calculator from the class, please return it. And then you have one iReady lesson that you're going to finish. It's going to be 5 points assignment. You must complete and pass the lesson. If you don't finish the lesson, it's going to be a homework. So I want everybody to finish the iReady in class. Once you've done that, you may begin working on the ACE problem in your notebook from your homework. When you're working on your homework, you can use a textbook, go to page 19 to 22. You should use the book that says comparing and scaling. Okay, and then go to page 19 and 22 of that page. 19. Go to page 19. So you're going to do number 1. And then you're going to do number 8. Number 8. You're going to do number 9. And you're going to do number 10. And please remember to check answers. You should be able to check the answers. Go to our Canvas page. Let me share my screen right here. So on our Canvas homepage, you can go to the textbook, click here to access the textbook ACE problem. And make sure you go to comparing and scaling. And you're going to look at the book pages for investigation 1. This is our first lesson. So investigation 1, make sure you download it in your Chromebook. And then once you have downloaded it, you can open up that download as a file and go all the way down. Look at the bottom corner for page 19. Page 19, and you will see the ACE problems there. Okay. Make sure you always check your answers. Go to modules, right? That's the page you're on, and make sure you're checking the answer keys. Click and check answers. All right. Get your homework done. Get your iReady done. Get your exit tickets done. Make sure you do the exit ticket first, and then the iReady, and then you can start working on your homework. And I'll check the homework next class. Bye.